So, hello, this is Dr. Hanaa Assil, and this is Unit 1 of the International AS Chemistry from Pearson Edexcel. And this is the paper that was done in January 2023. Let us take a look at the questions and discuss the answers. So, the first question says, which compound contains this number of molecules in 2.5 grams? You should know that number of molecules has to do with the number of moles. So if he gives me a certain number of molecules, I can get the number of moles. The number of moles is the number of molecules divided by the Avogadro's number, which is 6.02 times 10 to the 23. He gives it to you in the question, and even if he does not give it to you, you really should know it. So number of moles would be the number of molecules over the Avogadro's constant. So this number of molecules that he gives me comes out to be 0.039 mole. And the question is, which of these will have this number of moles in 2.5 grams? So for each of them, let's take a look at carbon monoxide. For each of them, if I have 2.5 grams, what is the number of moles? Well, number of moles of carbon monoxide, mass over molecular mass. So that is 2.5 over the molecular mass of carbon monoxide. This gives me a different number of moles. So this is not the one I'm looking for. For CO2, it also gives a different number of moles. For SO2, we get the same number of moles as what we're looking for. So this should actually be my answer. For SO3, it's a different number of moles. So obviously my answer is the SO2. So the SO2 will have the same number of moles as 2.35 times 10 to the 22 molecules in 2.5 grams. The second question says, what is the concentration of hydroxide ions in a solution containing 5 grams of barium hydroxide in 250 centimeter cubed? Okay, first of all, you should realize that barium hydroxide, when I dissolve it in water, it will give barium ions and hydroxide ions. But notice that 1 mole of barium hydroxide will give 2 moles of hydroxide ions. So if we say what is the concentration of hydroxide ions, then we should see the concentration of the barium hydroxide and then determine what would be the hydroxide ions. So what are we doing? Number of moles. The number of moles of 5 grams of barium hydroxide. If we have grams, number of moles is mass over molecular mass. He already gives me the molecular mass. So this 5 grams of barium hydroxide have 0.02919 mole. And that means the number of moles of hydroxide ions will be twice of that. So this is the number of moles of hydroxide ions. Now what is he looking for? He's looking for concentration. You should know that number of moles is concentration times volume, and that means concentration is number of moles over volume. So you put the number of moles that we have over the volume, which is 250 centimeter cubed, but remember we need to divide it by 1,000 to change it into decimeter cubed first. So this gives me this number of moles per decimeter cubed. So my answer is D. Okay. Question 3 says a sample of 15 grams of vanadium reacted completely with 7.07 grams of oxygen. What is the formula of the oxide? Of course, when he says what is the formula of the oxide, then he's asking you to get the empirical formula. Now, how do we get empirical formula? We said we write the masses or the percentage. Sometimes he gives you percentage and sometimes he gives you masses. The first thing you do is divide by what? The mass number of each one, which he already gives you, or you can get it from periodic table if he not give it to you. This will give numbers. Now you look at the numbers and you divide by the smallest in order to simplify the ratio. This comes out to a ratio of 1 to 1.5. Remember that we said we do not round up 1.5. We don't say this is 2 and we don't say this is 1. We write it as 1.5 and then we multiply all through by 2. So you multiply all the ratio. Instead of 1 to 1.5, it is actually 2 to 3. So your empirical formula is V2O3. Okay. Question 4 says, what is the pressure when 5 mole of nitrogen in a container with a volume of 1.5 meter cubed is heated to 500 Kelvin? When he gives you number of moles, volume, temperature, and he's looking for pressure, of course you need to use the ideal gas law, which he already gives you. So you should know that PV is equal to nRT. That means P will be nRT over V. Remember that number of moles, here we have 5 number of moles. What is R? R is 8.31, that's a constant. Temperature has to be in Kelvin. He already gives it to me in Kelvin. If he gives it to me in degrees Celsius, what should I do? Add 273 in order to change it to Kelvin. Now, over the volume, remember the volume has to be in meter cubed. He already gives it to me in meter cubed. If he gave it to me in centimeter cubed, for example, then I'll have to convert it. Okay, so this comes out to a pressure of exactly 13,850, but he rounds up his numbers, so this is approximately 13,900 Pascal. Which is the equation for the reaction of magnesium chloride with sodium hydroxide? So obviously he's talking about ionic equations. So let's write the equation out. This is the equation of magnesium chloride with sodium hydroxide to give magnesium hydroxide plus sodium chloride. We balance it, so this is the balanced equation. And then we take into account the states of each of these. So magnesium chloride is aqueous, sodium hydroxide is aqueous. Magnesium hydroxide is a solid. Remember that magnesium hydroxide, we said it does not dissolve easily. Both of them are small ions. They do not ionize easily in solution. So this is a solid, plus the sodium chloride, which is aqueous. Remember, when we're talking about ionic equations, we ionize only what is aqueous. So I have this equation to show the ionized solutions. And then we cancel whatever is the same on both sides of the arrow. What am I left with? I'm left with the magnesium ions, which are aqueous, hydroxide ions, which are aqueous, and the magnesium hydroxide, which is a solid. How many neutrons and electrons are there in this? Okay, we have Au, which is gold, of course, with a 2+ charge. Now, how many neutrons? How do we get neutrons? You should know that we get neutrons by subtracting the mass number minus the atomic number, or the big number minus the small number. So that means I have 111 neutrons. So my answer is A or B. Now, how many electrons? Remember, if you have 2+ on it, that means it has lost 2 of its electrons. So usually the electron should be the same as proton, which is the atomic number. So it should have 79 electrons, but 2+ means it lost 2 of them, so it has 77 electrons. The mass spectrum of an element is shown. What is the relative atomic mass of this element? Well, how do we get relative atomic mass from percent abundance of each isotope? You should remember the mass number of the isotope times its abundance, plus the mass number of the other one times its abundance, and so on, divided by 100. So here we have 4 isotopes, one with mass 90, 91, 94, 96, and the height, of course, of these peaks will show the percent abundance, or these bars will show the percent abundance. So we end up with 91.19. So that is this number, which is C. Which is the equation for the second ionization of the element J? Okay, what do we mean by second ionization? You should remember, second ionization energy is the energy required to remove 1 electron from each atom of what? 1 mole of gaseous plus 1 ion. So for a second ionization energy, I am starting with +1. So my answer has to be B or C. To form 1 mole of +2, because we're removing only 1 mole of electrons, so this is my answer. Question 9 says, which is a reason why fluorine has higher first ionization energy than oxygen? Well, first ionization energy, we said, is the energy required to remove the outermost electron. Now, if I have oxygen is atomic number 8, so it has 8 electrons, and this is the electron distribution of the 8 electrons. So to distribute the 8 electrons, 1s2, 2s2, 2p4, right? When we do for fluorine, fluorine has 9 electrons, so these are the distributions, 1s2, 2s2, 2p, how many? 2p5, right? Okay. Then we say, he's saying, why is it that fluorine has higher first ionization energy? Well, we are supposed to remove the outermost electron. Higher first ionization energy means it is more difficult to remove it, and this is because the fluorine has more protons in the nucleus. Remember that oxygen has 8 electrons, so it has 8 protons attracting these electrons. Fluorine has 9 protons attracting these 9 electrons. The electrons are in the same energy level. The outermost electron is both in the 2p, so either way we're removing a 2p electron, but the difference is that the nucleus has more protons in the fluorine, so it will be more difficult to remove that outermost electron, so it will have higher first ionization energy. Are we following? Which is the electronic configuration of chromium? You should remember that chromium was an exception to our distribution because chromium has 24 electrons. Now, how are we going to distribute it? We should actually distribute it by putting 1s2, 2s2, 2p6, and then 3s2, 3p6, 4s2, 3d4. But we said sublevel is stable if it is completely filled or half filled. So the 3d, which has 5 orbitals, if you put in 4 electrons, it just needs 1 more electron to be half filled. So instead of having 4s2, 3d4, we actually have 4s1, 3d5, so that both the 4s and the 3d are half filled, so they are stable. So this is the distribution of the electronic configuration of chromium. The 3d has 5 electrons, and the 4s has only 1. We took 1 from the 4s and we put it so that it completes the 5 orbitals, so that the 3d is half filled. Which combination of ions would be expected to form the compound with the highest melting temperature? Well, let's take a look at these combinations. We look at the periodic table. What does he have? He has lithium with bromine, or lithium bromide, magnesium oxide, strontium sulfide, rubidium chloride, and he's asking which of these has highest melting temperature. Highest melting temperature means strongest ionic bond, strongest attraction between the ions. Well, in order to have the strongest attraction between the ions, we need something with a higher charge, and a smaller radius. So if we're comparing between lithium and rubidium and magnesium and strontium, well, I'm going to choose magnesium or strontium. But then magnesium is a smaller radius with a higher charge. So this will, when it is bonded to oxygen, that will be a stronger ionic bond, so higher melting temperature. Which is a use of graphene based on its electrical properties. There are many uses of graphene, but he's asking for electrical properties. Now let's look at the choices that he gives us. A drill tip, remember, what do we use for drilling? Do we use graphene? We said drilling, cutting and drilling, we use diamond. So a drill tip would be made of diamond, not graphene. Pencils. Pencils are made of graphene? No, they're actually made of graphite. We said pencils, the substance inside the pencils is made of graphite. Now, touch screens are actually my answer. The graphene is used for touch screens because of its electrical properties. Graphene is also used for body armor, but that is because it is strong, not because of its electrical properties. Which molecule has the largest bond angle? Well, I would draw each bond angle and try to determine which one has the largest bond angle. BCl3 is boron with 3 bonds, so this is actually trigonal planar with a bond angle of 120. What about carbon dioxide? You should realize that carbon dioxide is a linear molecule, bond angle 180. Water is V-shaped, and this is 104.5 because the oxygen has 2 lone pair of electrons, so this pushes the bonding pairs closer together. Ammonia has 1 lone pair on the nitrogen and 3 bonding pairs surrounding it, so this is a pyramidal structure with bond angle 107. So which of these is the largest? Of course, the largest is the 180 for CO2. Which molecule is polar? Well, again, let's draw it. Let's see what these things look like. 1,1-dibromopropane. This is 1,1-dibromopropane. Would you expect this to be polar? Yes, because the bromines, the polar bonds in the bromines do not cancel each other. So this is the molecule that is polar. So this should be my answer. But let's look at the others. E12-dibromoethene. No, this would not be polar. The direction of polarity is in opposite direction. So this will cancel each other. Hexafluoroethane also. Each bond is polar, but the molecule as a whole is not because they cancel each other. Tetrachloromethane also. Each bond is polar, but then they are in opposite directions and they cancel each other. So the only one that is polar out of these choices is A. Prop2-ene-1-ol is flammable, toxic, and an environmental hazard. Which hazard symbol should be shown on its container? You should know what is the symbol for flammable, toxic, environmental hazard. So you should see that flammable is this hazard symbol, and toxic should be the one with the skull. Environmental hazard is the one in which a fish is dying there. And oxidizing, the other choice that you have there is oxidizing. Can you see the difference between flammable and oxidizing? So which of these has flammable and toxic and environmental hazard? This is, of course, a health hazard. This is the choice that you have in D. This is representing a health hazard. So he wants flammable, toxic, environmental, so that is A. Please be familiar with these hazard symbols. Which is the skeletal structure for 3,4-dichloro-2,2-dimethyl pentane. Pentane means you want a straight chain of 5. So let's take a look at A. I have 5 carbons, so this would be something pentane. Then he wants 2,2-dimethyl. Yes, I have at carbon number 2, I have 2 methyls. At 3 and 4, I have chloros, so this is actually my answer. If you follow all the other answers, they will not be the correct structure for that name. What is the name of a series such as the one shown? So if I have something, for example, all of them have double bond, or all of them have an OH, we call them what? We call them a homologous series. Okay, so when we have different organic compounds with the same functional group, these belong to a homologous series. Which is not a step in the reaction of chlorine with propane in ultraviolet radiation? Remember, alkanes react with halogens using what? This is a substitution reaction. It uses UV light, and this is a free radical mechanism. So if you remember, we have an initiation step in which the UV light causes the breaking up of the chlorine bond, the bond between the ClCl, to give 2 chlorine radicals. So that is an initiation step. Propagation step is when the chlorine radical removes one of the hydrogens from the alkane in general, and that forms the alkane radical, and then the alkane radical breaks up the chlorine to form a chlorine radical, and then this is a chain reaction or a propagation steps in which this continues to go on until 2 radicals join together. When 2 radicals join together, that is called a termination step. So A is possible, in which 2 radicals join together. B is possible. C is possible because we said the radical of the alkane will react with the chlorine to form a chlorine radical that will go back and react again. But what is D? D says the radical is reacting with HCl. No, it does not react with HCl. So this is not a step in the free radical substitution reaction of alkanes. Why does free radical substitution have limited use in industrial chemistry? We don't really use a lot of free radical substitution in industry. So which of these could be the answer? He says the reactions only occur in upper atmosphere. That's not right, because we said it can react, it can occur anywhere. Initiation requires UV radiation. Well, that's not the actual reason, because the UV light is not used in industrial reactions. Further substitution products are formed. Yes, this would be my answer, because yes, when we're trying to form, for example, chloromethane, this could continue to go on and not just give you chloromethane, it could give the dichloro, trichloro, tetrachloro, and so on. So this is not a very useful reaction because it can continue and give you further substitution products. When he says termination reactions produce unwanted products, well, termination products are formed in very low concentrations, so this will not be the reason. Which molecule can exist as EZ isomer? Remember EZ isomers? In order to have an EZ isomer, I need first of all a double bond between 2 carbons. And then these 2 carbons with the double bond between them should have different groups attached to each of them, right? So let's draw each of these and see if it can form an EZ isomer. This is 2-chloro-4-ethyl hex 3E. Can you see that? Now, it does have a double bond, so that's correct. But we said the 2 carbons on the ends of the double bond, each of them should have different groups attached. So this one does not have different groups attached. So this will not form EZ isomers. What about 3-chloro-2-methyl-hex-2-ene? Can you see the structure? Now, will this form EZ? Again, it has a double bond, but one of the carbons has similar groups attached to it, so this will not give EZ isomer. This one, 2,3-dimethyl-hex-2-ene, again double bond, but similar groups on one end. If we draw 2,5-dichloro-hex-3-ene, yes, we have a double bond, and we have different groups attached to each of the carbons on the ends of the double bond, so this will give EZ isomers. In section B, he's saying the structure of a compound X is shown. X is present in petrol. Give the molecular formula and the IUPAC name for X. Okay, to get the molecular formula, of course, I need to keep in mind where are the carbons, hydrogens, and so on. So if I write it out, this is the structure actually with the carbons and hydrogens written out. So count the number of carbons and the number of hydrogens. This will be C8H18. Now, how do I give the IUPAC name? Well, we said we choose the longest chain, so this is the longest chain. And we start from the number, from the side that will give lower numbers for the substituents. So this is the side that we start, so that we end up with 2,2,4-trimethyl pentane. We have 3 methyl groups. 2 of them are on carbon 2 and the third one is on carbon 4. If we count from the other side, it would be 2, 4, 4. So that we need to count from the side that will give you the lower number. Name the industrial process used to produce X from a straight chain. We said if we have a straight chain hydrocarbon and I want to rearrange it so that it becomes branched or so that it becomes cyclic, then this process is called reforming. Heptane is also present in petrol. Write an equation for complete combustion of heptane. Okay, we said heptane is something that has 7 carbons and it is an alkane, so it is C7H16. 2 times 7 is 14, plus 2, that's 16. And he's saying we need complete combustion. First of all, combustion means reaction with oxygen. To give what? Complete combustion gives carbon dioxide plus water, and then we need to balance. Remember, please note, he also says include state symbols. Now, heptane is a liquid, oxygen, of course, is a gas, carbon dioxide is a gas, and water is a liquid. So don't forget to include state symbols when he asks for it. Then he says, identify by name or formula a pollutant that may result from incomplete combustion. We said incomplete combustion of an alkane would give carbon monoxide. We said carbon monoxide is poisonous. You could also say carbon or soot. These are produced from incomplete combustion. Recently, sales of electric cars have increased. Give 2 environmental benefits of using electric cars and justify your answer. Again, sometimes we answer and we forgot to justify. Okay, so he's saying 2 environmental advantages of using electric cars. Well, remember, first of all, electric cars will not give carbon dioxide gas. Remember, when we use normal fuel, it gives carbon dioxide gas that causes global warming. So electric cars would not give carbon dioxide gas, so no effect on global warming. Another one could be the fact that also it would not release oxides of nitrogen. Remember, a normal fuel car would give oxides of nitrogen from the car exhaust, and that causes acid rain. So an electric car would not release oxides of nitrogen, so it would not cause acid rain. This question is about propene and some related compounds. Some reactions of propene are shown. Identify by name or formula the catalyst needed for reaction 1. So I look, where is reaction 1? It is propene reacting with hydrogen to give propane. This is the addition reaction of hydrogen to alkenes. Remember, alkene plus hydrogen, which catalyst do we need? We need a nickel catalyst. Name product A. Where is product A? This is propene reacting with chlorine. So if you look at propene plus chlorine, remember this is an addition reaction. Alkenes react with halogens so that the double bond opens up and you put Cl and Cl on the 2 carbons that had the double bond. This is an addition reaction of the halogen. So he's saying name the product. The product would be 1,2-dichloropropane. Identify by name or formula the substances needed for reaction 2. What was reaction 2? This was reaction 2. Propene becoming propane 2-ol. So I'm changing an alkene to an alcohol. What should we add to change alkenes to alcohol? Remember, to change alkene to alcohol, we're adding water in the form of steam and phosphoric acid catalyst, because we need water at 300 degrees Celsius. So water at 300 degrees Celsius is referred to as steam, of course, and the catalyst for hydration of alkenes or addition of water to alkenes is phosphoric acid catalyst. Draw the displayed formula of product B. What was product B? This is where propene, you add acidified potassium manganate. If we add acidified potassium manganate to propene, remember acidified potassium manganate is an oxidizing agent. If I add it to an alkene, do you remember? It gives the diol. The double bond opens up and becomes a single bond, and we put OH on each of the carbons. So this is a diol. This is produced from acidified potassium manganate with an alkene. Propene can undergo addition polymerization. Write the equation for polymerization of propene. Do you remember how to draw the addition polymer of propene? Well, propene is this. Now we need to draw the polymer. We said, how do we draw the polymer? The double bond becomes single bond, and you write a bond on the right and the bond on the left to join it to other molecules before and after. And then you see each of the carbons that had the double bond was bonded to what, and you copy it. So this is the polymer from propene, and of course polymer from propene is called polypropene, the same name. Don't forget to write that we're going to use a certain number of propene molecules. So we put an N in front of the propene in order to balance it with the N of the repeat unit that you're going to repeat N times. Okay, over 70 million tons of polypropene are produced each year. State 2 problems with the disposal of polymers such as polypropene. Okay, if we are disposing of polymers, you should remember polymers are usually, in most cases, non-biodegradable. So they will accumulate in landfill sites or they accumulate in dump sites. What was the other problem of polymers? When burned, they release toxic gases. So these are the problems or the disadvantages of using polymers. Hydrogen bromide reacts with 3-bromopropene to form 1,2-dibromopropane as the major product. Complete the mechanism to show this reaction. So this is reaction of an alkene with HBr. You should know how to draw this mechanism. This is electrophilic addition. So the double bond will give electrons to the slightly positive H of the HBr, and the electrons of the HBr will go to the slightly negative Br. So this forms a carbocation. The carbocation is then attacked by the Br minus, because the Br now has the electrons from the bond, so it's now a Br minus. It attacks the carbocation, and this forms the, in this case, it is forming the 1,2-dibromopropane. Remember that he's saying hydrogen bromide reacts with 3-bromopropene to form 1,2-dibromopropane as the major product. So this product that we have is the major product. What would be the minor product? Remember, we had a choice of putting the carbocation either on that second carbon in the middle. In this case, this is a carbocation that is a secondary carbocation, or I could have put the hydrogen in the middle so that the carbocation is on the carbon at the end, and that would be a primary carbocation. And we need to remember that he's saying, why is it that the 1,2-dibromo is the major product? Well, this is because the 1,2-dibromo was formed from a secondary carbocation. In order to form 1,3-dibromo, then I would have a primary carbocation, and you should remember that a secondary is more stable than a primary. So the 1,2-dibromopropane is the major product because it is formed from a secondary carbocation, while the 1,3-dibromo would be formed from a primary, which is less stable. Oxygen is vital in the treatment of respiratory diseases. Oxygen is traditionally produced by the fractional distillation of air. Suggest one difference between fractional distillation of air and fractional distillation of crude oil. Do you remember the fractional distillation of crude oil? We said the crude oil is heated and vaporized, and it goes into the fractionating column and so on. What about fractional distillation of air? Well, air is originally a gas. So in order to do fractional distillation of air, I would need to liquefy it first. So the air needs to be cooled under pressure to change it to a liquid, and then we can do fractional distillation to separate the different components of air, because we know that air is a mixture of gases. Now, when we cool it under pressure, it becomes a mixture of liquids, and that can be separated by fractional distillation. Hospital patients sometimes need to breathe air with a higher than normal concentration of oxygen. The oxygen concentration can be increased to 90% by passing dry air through a tube filled with something called zeolite, which absorbs most of the nitrogen. Now, we know that dry air contains 21% of oxygen by volume. The average human breath has a volume of 500 centimeter cubed. And he's saying, calculate the volume of air, and he wants it in decimeter cubed, that would have to pass over the zeolite to obtain 500 centimeter cubed of gas containing 90% of oxygen by volume. So I'm trying to get 500 centimeter cubed of gas made up of 90% oxygen. How do I get that from a mixture that has 21% originally? Okay, so what we do is we find out the volume of oxygen needed for one breath. So one breath needs 500 centimeter cubed, and if the gas is 90%, then that means I will need 450 centimeter cubed of oxygen. So how much air in general will I need? The air has 21%, and I want 450. So this will be 2,143 centimeter cubed of air required. He wants it in decimeter cubed, so please divide by 1,000. Nitrogen molecules bind to zeolite using their outer electrons. Draw a dot and cross diagram of the bonding in a nitrogen molecule. So we want to draw dot and cross of a nitrogen molecule showing only outer electrons. How do we draw that? Remember, nitrogen is in group 5, so it has 5 electrons. It needs how many? It needs 3. So each of the nitrogen atoms will donate 3 electrons to be shared between them, and each of them still has the rest of the 5, so each of them has 2 electrons that are not involved in the bonding. Liquid oxygen is transported across the world. Liquid oxygen has a density of this. Calculate the volume of gas in meter cubed measured at room temperature and pressure that can be obtained from a bottle containing 13.9 decimeter cubed of liquid oxygen. Okay, so we're starting with liquid oxygen, and he's giving me a certain volume, and you remember that density is mass over volume, so I can get the mass of oxygen in this liquid bottle, or this bottle of liquid. So the mass is density times volume. Density he gives me, volume 13.9. I get a mass of this in grams because the density was in gram per decimeter cubed. Now I can get the number of moles of this amount of oxygen. So I have a mass of 15,846 grams. Number of moles is the mass over the molecular mass of oxygen. Of course, oxygen is diatomic, so it is O2. Each oxygen has a mass of 16, so the MR of O2 is 32. This gives me the number of moles of oxygen. What does he want? He wants volume. Okay, volume is number of moles times 24, because this is at room temperature and pressure. So the number of moles times 24, this gives me a certain number in decimeter cubed. Remember that the answer here comes out in decimeter cubed. He wants it in meter cubed, so you divide by 1,000. This is 11.88. Please be careful about the rounding up of this. So if you're going to write it to 1 decimal place, this is 11.9, not 11.8. The total mass of the bottle is 80 kilograms when it is full of oxygen. Calculate the mass of the empty bottle using the mass that we calculated of oxygen. So if he says the total mass of the bottle plus oxygen is 80, so the mass of the liquid oxygen was 15.85, then the rest of the 80 is the mass of the empty bottle. And that means that the empty bottle has 64 kilograms. And he's saying, explain why the container needs to have such a large mass. Why is it so heavy? Well, because the container must have thick walls to withstand the high pressure of the gas inside it. So these bottles are usually heavy. The next question is talking about radii of ions of some successive elements in the periodic table. And he's saying, plot the graph of the data. So he gives me the ion and the ionic radius. If he does not label the y-axis, then you have to label it and you have to divide it. So how are we going to divide it? We want ionic radius in PM, and the numbers go up to what? 170 something, so you can distribute the numbers like this, plot with small x's, and join with a line of best fit. So this would be a typical graph. Predict the radius of the magnesium ion using a straight line of best fit on your graph. Now, how do we get the radius of the magnesium? We go up from the magnesium up to the graph and go horizontally. So according to this graph, it is 76 p.m. Please remember, if he says that he wants the graph in a straight line of best fit, then it has to be a straight line of best fit. So please check how he's telling you to connect the graph. Explain the trend in the ionic radii from the nitride to the aluminum ion. So this is the graph we had. Now explain why from the nitride to the aluminum, the ionic radius is decreasing. Now, if we look at the periodic table, what are we looking at? From nitrogen to aluminum, you can see that the nitride ion, oxide ion, fluoride ion, sodium, magnesium, aluminum ions, they all have the same number of electrons. But they differ in what? They differ in the number of protons inside the nucleus. So why is the ionic radius decreasing? Because we have the same number of electrons, same number of energy levels, but they are attracted by increasing number of protons, and that is why the radius is decreasing. Sodium and fluorine react to form a compound. State the structure and bonding of sodium fluoride. Of course, you should realize that sodium fluoride is an ionic bond. And what would be the structure? The structure is a giant three-dimensional crystal lattice. Explain how the electrical conductivity of sodium fluoride provides evidence for the existence of ions. Well, the sodium fluoride conducts electricity only when molten or in solution, because when molten or in solution, the ions are free to move. It would not conduct electricity as a solid because ions are fixed in the crystal lattice and are not able to move, so this shows the existence of ions. Explain why the fluoride ion is difficult to polarize. Well, if you look at the fluoride ion has one negative charge and a small ionic radius. So this electron cloud is difficult to distort when it is next to a sodium ion or a lithium ion and so on. This question is about aluminium and its compounds. State the shape of a molecule of aluminium trichloride. What would be the shape of AlCl3? Of course, Al is the central atom, no lone pairs on the central atom. We have 3 bonding pairs of electrons, so this is the shape which is trigonal planar. Okay, he wants the shape of the molecule. This is trigonal planar. Aluminium chloride can exist as a dimer formed from 2 molecules of aluminium trichloride. Draw 2 molecules of this dimer showing the bonding between the 2 molecules. Remember, we said aluminium chloride will dimerize. Why can it dimerize? Because each molecule has chlorines that have extra lone pair of electrons. So these can be used to make a coordinate bond or a dative bond with the aluminium of the next molecule. So this is what the dimer looks like with coordinate or dative bonds between the chloride of one molecule and the aluminium of the other. Aluminium trichloride reacts vigorously with water to produce hydrogen chloride and aluminium hydroxide. Write the equation for this reaction. He doesn't want state symbols. So what are we doing? Aluminium chloride plus water, and he's saying it will give aluminium hydroxide plus hydrogen chloride, and all you need to do is balance. Remember, he says write an equation, it has to be balanced. Aluminium trichloride also reacts with sodium hydroxide. Calculate the maximum mass of aluminium hydroxide precipitated when excess aluminium trichloride reacts with 150 centimeter cubed of 1.5 mole per decimeter cubed sodium hydroxide. So he's giving me information about sodium hydroxide, and he's asking about what? the mass of the product, the mass of aluminium hydroxide. Okay. He gives me information about sodium hydroxide, so the first thing we do is number of moles of sodium hydroxide. Concentration times volume. Again, the volume has to be in decimeter cubed. You divide by 1,000. So this gives me the number of moles of sodium hydroxide. What's the next step? I look at the equation. How is it related? You can see that the equation says 3 moles of sodium hydroxide will give 1 mole of aluminium hydroxide. And that means number of moles of aluminium hydroxide should be the number of moles of sodium hydroxide divided by 3. This gives me the number of moles of aluminium hydroxide. What is he asking for? He's asking for mass. How do we get mass? Mass is number of moles times mR. What is the mR of aluminium hydroxide? You calculate that. Mass of aluminium plus mass of 3 oxygens plus mass of 3 hydrogens. This comes out to be 78. Then I can use that to get the mass of aluminium hydroxide, number of moles times molecular mass. This gives me a mass of 5.85 grams. Describe the metallic bonding in aluminium. Okay. Remember that aluminium is in group 3. That means each atom has 3 delocalized electrons floating around it. And the metallic bond is the strong electrostatic attraction forces between the positive ions and the sea of delocalized electrons. This is the metallic bond. Remember, he's asking for the metallic bond, so you have to say it is attraction between something and something. So it is the attraction, it's strong electrostatic attraction forces between the positive ions and the delocalized negative electrons. Last question. Explain how metallic bond leads to the properties of electrical conductivity and malleability shown by aluminium. So why does aluminium conduct electricity? It conducts electricity due to the presence of free moving delocalized electrons. Why is it malleable? It's malleable due to the fact that the layers of positive ions can slide over each other when heated or hammered. Are we okay? We understood this? Okay, so this is the end of this paper. Please share, like, and thank you for listening.